When we hear about advanced artificial intelligence, systems capable of outthinking human experts, we usually picture a very specific setting. We imagine walled-off corporate campuses in Silicon Valley, where billions of dollars of hardware sit quietly behind closed doors. Or we look across the globe and picture heavily centralized state networks. In places like Beijing, immense computing power is strictly controlled from the top down, serving a very unified, tightly managed agenda. Both of these approaches treat cognitive power like an exclusive product. It is something to be owned, locked behind a commercial paywall, or carefully rationed by a central authority. Right now, India is writing an entirely different blueprint for what artificial superintelligence can be. Instead of consolidating power at the top, they are engineering an open network meant to serve the entire population from the ground up. The core idea here is a complete departure from the global norm. India has decided to treat massive computing power like water or electricity. It is being built as a public utility, a sovereign grid that any citizen, researcher, or local startup can tap into. By making these tools widely available, the country is proving that the next leap in computing does not require a monopoly. It can be constructed entirely as a foundational public good. To build a system this advanced, you need physical resources. Specifically, you need enormous clusters of high-performance computer chips, the brains of the operation, working together to process mountains of information simultaneously. Historically, giant foreign tech companies have hoarded these chips, making it nearly impossible for independent creators to compete. To solve this, the Indian government established the IndiaAI Compute Portal. Backed by an investment of roughly $1.2 billion, this portal acts like a series of public power plants for artificial intelligence. The state is making a massive network of 38,000 high-performance processing units available to the public. Because this hardware is state-backed, the costs drop dramatically. Domestic researchers and small businesses can rent this immense computing power for as little as 65 rupees, about 80 cents an hour. By democratizing the physical hardware, local innovators are no longer priced out of the market by the massive rental fees charged by overseas tech giants. But hardware is only half the equation. An intelligence system is only as smart as the information it reads. If you train a massive computer solely on English websites from the United States, it will be completely blind to the realities of a rural village in Punjab or a farming community in Tamil Nadu. That is where a platform called AIKosh comes in. It serves as India's public data library, offering over 12,000 distinct, locally sourced collections of information. Developers can use this data to teach their systems for free, without paying the heavy fees usually demanded by private companies. And to make sure these systems actually understand the people they serve, India uses a system called Bhashini. This project organizes data across the country's 22 constitutionally recognized languages, ensuring the technology speaks like a local. This contextual layer guarantees that the resulting technology understands native scripts and local dialects. It completely closes the digital divide, ensuring that millions of non-English speakers can interact with advanced computing naturally. Without this local infrastructure, countries fall into a trap. They export their citizens' raw, daily data to foreign servers, and then have to pay a premium to buy back the finished software tools built from that exact same data. India's solution is strict data sovereignty. By keeping the computer processing and the daily data logs safely inside local borders, the country retains complete ownership of its digital resources. We have seen this strategy work before with digital payments. By building an open, public framework, the technology became so accessible that local street vendors use it for everyday transactions. Applying this exact same localized logic to artificial intelligence ensures that the systems running domestic hospitals and schools answer directly to Indian laws and ethics, rather than the profit margins of a foreign corporate board. As these systems mature, they evolve past simple assistants that write emails. They become advanced tools capable of solving complicated problems and making complex decisions on their own. When millions of local researchers can suddenly afford this much brainpower, they begin solving thousands of small local inefficiencies at once. According to India's central policy think tank, This widespread access is projected to add $1.2 trillion to the nation's GDP over the next decade. In agriculture, for example, these public systems can cross-reference soil data with weather feeds to deliver farming blueprints in regional dialects. This helps farmers protect their yields from sudden monsoon shifts, turning data into a higher income. In healthcare, these same tools can scan images at small local clinics to catch early signs of cancer automatically. It brings expert-level screening to areas that lack enough specialized doctors, saving lives for a fraction of the traditional cost. The true objective of an Indian superintelligence is the creation of a localized cognitive fabric, a public resource that weaves into the background of daily life to solve real-world problems. Of course, unleashing intelligence at this scale carries risks. Without oversight, these systems could generate convincing fake videos or enforce hidden biases against marginalized groups. To counter this, India's Safe and Trusted policy mandates that these systems must be open for public audit. This prevents critical infrastructure, like banking or medical records, from being controlled by a single commercial monopoly. Treating raw processing power as a basic utility and guaranteeing multilingual access as a civil right represents a profound act of digital self-determination. India is engineering a framework where the ultimate value of advanced technology is measured by the common good. This ensures that as machines grow more capable, they remain deeply connected to the humans they are meant to serve.